evaluate the definite integral. And we have the definite integral from 0 to 3 pi over 2 of sine squared of t dt. So looking at our integrand, we think, we don't have a general antiderivative formula for this, but we can recall the double angle formula, or excuse me, the half angle formula. So we know if we let some k be a constant, that sine squared of k theta, or t if you'd like, is equal to 1 minus cosine of 2k theta divided by 2. And so we can use the half angle formula to rewrite sine squared and then evaluate this integral as a general antiderivative. So we can rewrite this as the definite integral from 0 to 3 pi over 2 of 1 minus cosine of 2t divided by 2 dt. And I'm going to pull this constant 1/2 out in front. So we have 1/2 times the definite integral from 0 to 3 pi by 2 of 1 minus cosine of 2t dt. And now we're ready to go ahead and integrate. So we have general antiderivatives. So this is equal to 1/2 multiplied by t minus sine of 2t divided by 2. And we evaluate from 0 to 3 pi over 2. And so here's our evaluation. We have 1/2 multiplied by 3 pi over 2 minus sine of 2 times 3 pi over 2 divided by 2. And now we're evaluating at the lower bound, which is 0. So we have 0 minus 2 times 0 gives us 0 all over 2. And we can simplify. So these 2's cancel each other right out. And we know here that sine of 0, of course, goes to 0. So we are left with 1/2 multiplied by 3 pi over 2 minus, we have sine of 3 pi all divided by 2. And we know that sine of 3 pi goes to 0. So we are left with 1/2 multiplied by 3 pi by 2, which leaves us with the beautiful final answer of 3 pi divided by 4.